Alright, this is a short video for our standard connectivity test. So we're going to show you some of the different options for probes for our USB oscilloscope. Here's the product itself. It's got a USB port on the side there, and we have two USB connectors. The white one here is going to Mikhail's laptop, and he's been doing most of the Python work on that. And then we'll also test it on my trusty HP laptop on the black USB connector here. And on the front, we have two BNC connectors, one for each channel, and two switches underneath. And these switches allow you to select between either hooking up a standard BNC cable, like this one that you might get from the bookstore for pretty cheap, or one of the fancier 10x attenuated scope probes with these nice tips on them. Those sell at the bookstore for probably about $45. And then the switch selects between the two. So for our first test here, we'll hook up Mikhail's laptop. Like that. Alright, and it's got a power lights on. And we'll start by hooking up a 10x probe. In case you're wondering what we're measuring here, we've got a function generator which is generating a 10 kilohertz 1 volt wave. And here's the readout on the TechScope to prove it. It's about it's almost exactly 1 volt and 500 millivolts in each direction from ground. So that's coming down here to this mess of wires. From the top, this is our signal coming in. This is going to the TechScope so we can measure, we can just verify the signal. This is the connection from our BNC, which isn't hooked up right now. And this is our 10x scope. So if we go over to the computer, and we'll start Python up. There it is. And there's the signal. Looks pretty small right now. 1 volt's pretty small signal, so we'll change the vertical scaling. There it is. And trigger on the rising edge. So there you have that. We can then switch over to the standard BNC probes. Let's pull this off. Flip the switch over to the BNC, and kind of hard to do with one hand, but there it is, tight enough anyhow. And here you see you can select that we have a BNC probe and trigger type, and there's exactly the same signal again. Also, we have a mode which allows you to measure small signals more accurately using the BNC connectors. So we can switch the switch over here that normally should be on the BNC setting while we've got the BNC probes hooked up over to the 10x attenuated probe setting without changing the probes. If we do that, then on the Python interface here we select that we want our BNC with no seatbelt. And now we have the same very low amplitude signal spread across a wider range of ADC values. So this is really good for measuring small signals. You won't be able to survive hooking up large signals to this, so if you want to be really safe, leave it on the other setting. But that's that. We can do the same thing over on this computer. This is my HP. We'll plug the HP in. And yeah, we'll switch it back over to the BNC setting there. And there it is. Starts up. Channel 1, very small signal. Oops. Set this to BNC. And zoom that in a bunch. And we can set a trigger. And there you have it. Pretty much perfect again. If we pull this off, we can try the BNC probes on this computer. I mean the 10x probes, rather. Yeah, get that for me. Okay. Here we are again. We'll choose that we have a 10x probe on the rising edge. And there's the same signal again. So that's it. 2 different laptops, 2 different types of probes. Same signal.